Perfect. Thanks a lot, Peter. Thank you for the nice introduction. So Linus and I will focus on how to create reproducible and shareable computing environments. We are part of the Swiss RSC community, so greetings from Switzerland. And yeah, let's start with a short overview. So we'll do a quick introduction on the terminology because there are quite many terms flying around. Then Linus will do a deep dive into one specific technology for um, creating rerunnable or reproducible environments. We will do some case studies from personal projects that we did with this technology compared to Docker, and then finish off with a conclusion. Um, so for introduction, let's start with some terminology. What I found to be useful is the following paper from 2018. So they find five important terms around this about rerunnable code. First one is simple. So rerunnable code should be in a state that is executable. So it should include all the knowledge that you need to run it. First, it should be repeatable. So it should, if you do a simulation, it should give the same result if you pin the seeds, or at least give the same statistics. It should be like all of science reproducible. So other investigators, researchers should be able to reproduce, for example, certain plots of your paper. This also is connected, of course, to open research data. Last, it's of course really nice if our code is reusable, if we can for example, have some module that is taking care of the data loading in our experiment, and then when you can reuse this for different experiments, of course, they save time. And last, it should be very applicable. For example, in the field of cryptography, we might have some, or also in mathematics, we might have some pseudocode. And then if you have a reference implementation, then of course this helps and take out ambiguity. Great. So, but actually, before we get deeper into this topic, I just want to share one experience how I got interest in software engineering or creating reproducible, sort of like rerunnable code. So my background is actually from physics. So 2 years ago, when I did my master's, I had the chance to visit a group in Tokyo. And so it was always my dream to do something with the standard model to challenge it. So I was really lucky that I could visit this group in Tokyo. This was an experimental physics group. And so basically what they tried on a really high level is to understand why we see more matter than antimatter in the universe today. So the approach that they had was not with these huge colliders like at CERN, but actually by looking at cold atoms. So they try to measure the electric dipole moment of these elemental particles and see if this electric dipole moment is bigger than what the standard model predicts. And so I was really excited when I arrived there. So they had built this experiment, like a full room of apparatuses, and was really, the engineering was amazing. I was really surprised, and I was really excited to start the experiment. But then when when it was the experiment day, everything was different than what I expected. So actually we had everything on LabVIEW, and we had to basically start the experiment, wait 5 minutes, take out the data, and then repeat this all over and over again. And so you can imagine I was seeing so much opportunity, and this is a little bit what I see with the thing when we don't have rerunnable code. So in this sense, it was the symptoms that we saw was that automation was non-existent or hard, and also collaboration was really challenging because the experiment was not, and also the analysis was not really done with code. Of course, this is the cure is really simple. Of course, for you as RSCs, you know the solution. You just define all steps of the experiment with code. So you control the experiment with code, use proper package management so that different people can work at the same time on the code, on the analysis. And then you also manage the environment variables nicely. This, of course, not just environment variables of your code, but in this sense also from the simulation or from the experiment. So if you have a full room of apparatuses, then of course you need to know about the settings. Yeah, with some really basic changes, so basically these 3 plus Git, we could really automate this full experiment, and I'm really fascinated. So Nagase-san, then he's a PhD student that in this group, he did this in like 2 months, and since then he uses this code, and he has been really successful with this. So he's now much faster. He can run the experiment for hours in an automated way. He can start off with analysis right away, and I think this is a great example of a case where investing in the basics is often much more valuable than using the most fancy technology or tool. And so in this talk, we will not focus on version control or package management, but something that I found is often in many research groups an issue. It's environment management. So you want to onboard a new student or engineer, and now you want to basically set everything up. And this is often a time-consuming take or task. Then on a higher level, you also would have containerization. We will also talk a little bit about how you can use DevBox together with Docker. Basically DevBox for development and Docker then for more of deployment. What we'll not cover today is, or we just cover a little bit of workflow automation with GitHub Actions, but then like configuring hardware or configuring infrastructure in the cloud is it's not part of this talk. Maybe before we dive into DevBox, just one last thing. So how do we evaluate such tools when we want to create reproducible compute environments? I mean, start with something that is easy to use, should integrate with Git. It's also nice if it integrates with different operating systems, because not all of us have like a fancy Mac, or maybe yeah. It should allow to have also your own libraries. So maybe something that is not published yet. It's nice if you can integrate this in your environment management system. It's nice if it works offline, especially if you're in a location with like limited bandwidth. And of course, performance, cost efficiency. If it's open source with a permissive license, then everyone can access it. And I think this is a great start. Yeah, so with this, I want to hand over to Linux for a deep dive into DevBox.
Okay, thank you very much, Roman, for this introduction. So my name is Linus Kasser. I work at the EPFL in Switzerland. Work for the C4DT, which is the Center for Digital Trust, where we work on trust-related projects. And so the C4DT is not a high-performance computing thingy, or we do some GPUs because we also do some LLMs. But we're mostly working on our laptops, and then we do have some CI/CDs that we want to use to make it reproducible. So come a bit from that part. So for this deep dive into DevBox, I want to first go into a bit what are the environment types that exist. What is DevBox? So how does it work? I will give you a simple use case also, as Roman said, just a little bit how it works with GitHub Actions and in Docker. And then in the second part, I will look at 2 case studies, so 2 projects where we use DevBox to manage the project and make it much more runnable. So first of all, I copy and adapted this thing from Richard Fitzjohn's talk on Tuesday. I don't know whether you saw it. and I thought it was very nice. I did change a bit the titles. But so I just want to point out, as Roman also already did, the difference between reproducible and rerunnable. So reproducible is really having the same binary bit for bit and having the same output bit for bit. And rerunnable, for me, if the binary is a little bit different, that's not a problem, but at least the problem domain, the output should be the same. So I'm not interested in having something where you can prove that your signal binary that you have on your Android phone is exactly the same signal binary as you have from the source code, which is one of the problems they solved. I just want to be able to have my project on my laptop, give it to a new student, and he can go right away without having to install things in a very complicated way. So question to you, to the audience, sorry for those remote. What do you use for rerunnable environments? Just shout out, what do you use?
Conda.
What?
Conda.
Conda, okay, very good, yeah. Conda, that's Python, no?
No, it's all sorts of stuff.
All sorts of stuff, okay. Conda, others? Docker, yeah. Wonderful. I tried to use Docker with Rust, and it was always so slow because Rust has so many files, and then when I mounted the directory virtual, it was really slow. Other things you're using? Aptena. Sorry? Aptena, okay. Have to look into that. Don't know it, yes? Okay, SPAC, yeah. Yeah, SPAC is also one that I put here more into the high-performance computing, also like with easy build. As I said, I'm come more from this part here from a developer where I develop on my machine, and I want to have other people also be able to develop on the machine. And I'm not so much interested in having my things run on 1,000 different nodes at the same time with the same thing. So here, they're also, well, obviously you're all already moved along, so you don't have NVM, GVM, pip, or all that. That's good for you. They are all language specific, and some of them are even machine-wide. So if you have two different projects with two different versions on your computer, it gets complicated. There are a fluff of tools that exist which influence the path. So the path is just a place where your computer looks, where you will find the binaries. And all these tools, they write different binaries in the path. And so you can, with some of the tools, you can actually use different paths in different directories. So you can have two directories for two projects, and then you can have different binaries being run depending on the directory, which is very nice. And so this is where DevBox is useful. There's also Flux, which is similar. Then there's Docker, Flatpak, Snap. They are more for distribution, so for actually taking the program, and then you can make a Docker image, and then you can use that. So just to show a bit where I think DevBox really shines. So it's not in the distribution part. It's really when you have these different versions for different directories. This is the obligatory image from XKCD that you need to show, with the Python version that runs on his computer. So there's all kinds of different things for Python and also for all other tools. Okay, DevBox. Too long didn't read. What you need to know, DevBox, it's portable. It does isolated dev environments. It runs on any machine. So like Roman also said in the beginning, you want to have it on Linux, Mac, at least Windows subsystem for Linux. It does not Windows itself. It does only Windows subsystem for Linux. So that's a small restriction. So the biggest point why I like DevBox over ASDF or Brew or whatever is it is based on Nix. And Nix is very, very nice for one reason for me. It has 400,000 versions of 80,000 packages. So if you have a specific tool that you want to use on your computer, there's a big chance that Nix has it. There's even a bigger chance than some other tools. So this, sorry for this graphic, it's a bit small. So here you have the number of packages in the repository on the horizontal, and on the vertical is the number of fresh packages. So Fedora has already quite a lot of packages. Ubuntu has some more. But Nix, I mean, it's just over here. So Nix really has a lot of packages. They're very much up to date. So this is very nice. Versions in Nix, in DevBox are then stored in a DevBox.json. So for those who come from the Node part with a JavaScript, it's akin to packages.json. It's very similar. Devbox.log is a package log.json. When you want to run your projects, you have devbox shell. You also have devbox run. I will show that just afterwards. Then you have an environment, and devbox then sets up your path to all the specific binaries that you want to run in your specific directory. So you really have your directory with all the binaries that you chose, and if you move it to another computer, you will have exactly the same thing. So this is really nice, and for me it was wonderful when I discovered that. Before I always had the readme.md where you have all the install this, install this, install this, install this, and now you put all that in a devbox JSON and it works, fingers crossed. You can even use something called dir end, which makes that if you cd into directory, it will automatically launch everything. I don't use that, but some people like this. Okay, let's take a very simple use case. So you have one project with Node.js version 20, another project with version 22. How do you solve that usually? So if you have two different Node versions, how do you use that usually?
Volta.
Sorry?
Volta.
Volta up, okay. Somebody else? Other?
NVM as well.
NVM, yeah, you can also use VM? PMPM, okay. I discover a lot of tools, that's good. Need to write them all down, okay. You can also use devbox. So the idea here is to, just to show you how this would work. So here I create a directory, and I do once devbox init, which creates a devbox.json. And then you can add all the packages that you want. So here you have Node.js at 20. So it's a bit similar like brew that works on macOS. You can also give at the at, you can give the version. Sometimes I like to use my Vim and Git. And then devbox churns away and installs all these packages. So the packages are installed in the /nix. They are installed globally on the computer. There's also a cache, so if you rerun it, it will take the same packages from there. And then you can do start the environment with devbox shell. I always add -- pure, which makes that it does not include any system commands. So I'm sure that whatever I type, whatever command I run, it comes from devbox. So there is not some other binary which is still hanging around somewhere on my computer, which will not be available on somebody else's computer. I just have the pure devbox environment. So that's sometimes an advantage, sometimes not, but at least to making sure that it works on others' computers, that's good. And then I can have here the version, and it's v20, so I'm happy. I can do the same thing with the second directory. Here I do add Node.js 22. And if I create the shell here, I have now the version 22. And if I would go back to the other directory, I would have again the version 20. So now I have two directories which have different devbox.jsons. And I can develop one where I need the Node version 20 and the other where I need the Node version 22. Here a little overview of how that looks. So here I have these package versions in devbox.json, and I can have some startup commands. So saying every time before you run something, you need to run npm CI to make sure that all the packages are installed. And here I can have a small scripting session where I say, okay, if you run devbox run test, then this command here will be run. So it is a very easy JSON format. There are some, if you look at Nix, Nix can do the same. Who here knows Nix? Do people know Nix? Some? Oh, okay. So the Nix flakes, do you use Nix flakes? No? Yeah, some, okay. I looked at them and I was afraid. So it's really, they seem to be very powerful, too powerful for me. I just want to say I have this version of the program and I want to install this thing and I want to run these scripts. I don't want anything more, so for me devbox is just wonderful. If you are really a geek, then Nix might be more for you, but for me this is just wonderful. And I hope I can convince you and that you give it also a try. So you have some similar to a Makefile. So you can, you can set some environment variables also. You can initialize when starting, what I showed, and run commands. So here an example of how that would look like. So I have a dark screen, and so on Mac I'm always, when I do ls with the colors, the directories always are deep blue, and deep blue on black is not good, so I put this ls color, so I have yellow directories. So you can put that in the devbox JSON. I thought that was nice. You can set the path also, of course. So here I set the path that the node modules are always available. And this is the init hook. Again, this is things that are, so I have my color directory, which I like a lot. And here are just 3 different scripts that I directly use for this devbox JSON. So this is a very simple example of devbox JSON, how you can make it to run, and then somebody else who runs it on his computer. If he also has a black background, then he will be very happy to have also the yellow directories and not the dark blue directories. Now you can run the commands, and you can also use this devbox shell to continue development. And this works very nice, and in fact, I'm very happy with that. You can also do GitHub actions. I show that just afterwards, a bit in more details, how that works. And this is really useful. And you can create Docker files directly, which will include the whole development part of, so the whole development environment of the NICs. I will show you there is one downside with that one. Show you how I will solve that. Perhaps later they will make it simpler. And you can do a lot of other things with devbox. But for me here, the goal is really to convince you that if you want to have rerunnable environments, devbox, really give it a try. I think it's worth it. Going on to case studies, I have one project that is quite complex, that has a whole CI/CD pipeline, and that I want to make available also for students. And every time I do something for students, it's always the problem. It takes them a week to get up to speed, to have everything installed, to have the first compilation, to have the first run. It's always a hassle. And so I will look this semester whether it will be easier. So I have this project called Fletcher, where I created a full CI/CD pipeline, so testing, package publishing, and deploying. So just show of hands, who has also projects where he really has the full CI/CD pipeline from testing to package publishing to deploying? Who does that? Oh, wow, cool. That's nice, that's nice. So for me, one of the problems I have when I do that is that if I develop on my computer, I have some versions of the software again. If I test it in the GitHub workflow, the GitHub workflow installs the packages, and it's yet another version. And then you do the package publishing. You perhaps have some Docker image creation. There you have, again, all the versions that are in there. And so it's always different versions. And with devbox, you can make these versions just in one place, and you don't have the versions in 3 different places. Yes. So I will show you at this example of this Fletcher project that I use for the students. It's a nice project, a pet project of mine, short ad session here. It's about a decentralized system in your browser. So instead of having to install something on your computer and then connect into it, you just go to it with your browser, and you are part of a decentralized system. I thought it's very nifty, and yeah, developing that over the years. Anyway, that's not the subject here. But we'll show you a bit how to make this. So it's based in Rust, so how to install the whole Rust toolchain, how to make only one source of tool versions, and then how to use it with GitHub actions. So for the devbox to install the Rust, I showed you before how you have this init hook, where you can tell devbox every time you run a command, every time you run a shell, you run these commands. And here I use this init hook to install the Rust toolchain. This is because Rust, they only give you the Rust up binary. So also Nix only has the Rust up binary. And then the Rust up command needs to install the Rust system. That's the way Rust works. And so, well, we have to go with it. And for devbox, this is not a problem. You can do that very easily. And you can say here, OK, if this toolchain is not available yet here, I install it. The same thing for the WASM. So as the thing needs to run in the browser, you need the WASM. And so you need to have also that thing. And you can say it's just 2 commands, but I tell you, for semester students, just 2 commands, installing them. Sometimes it takes them a long time to find the right thing and how it works. And here it's just done automatically, which is very nice. Now you can use this also in the GitHub Actions. So before I had this installation of Trunk, which is a tool for Rust in WASM. I had this part here. I had the WASM pack the actual WASM pack from Rust. I needed to install these with the correct versions. So I can remove all that and replace it with the devbox. So here I just give the devbox install in the GitHub Actions. And now instead of, I'm using make files. Instead of using make cargo build, I write devbox run -- make cargo build. And now when I write devbox run, what it will do, it will look at the packages that need to be installed. It will install the packages. Then it will run the init hook, so it will install all the Rust. And then it will run the make cargo build. And so this is, to me, this is really nice. So I have all my versions are in the devbox JSON. I can use it locally on my computer. I can use it in my GitHub workflow. And I could also use it in a Docker file image creation. Always the same versions. Everything will always use the same versions. This is so nice, and you don't have different versions in different parts anymore. There are some downsides, of course. One of the things is that the devbox has everything in it. So it's really its own system. And when I say everything, it's even the libc. So devbox doesn't even use the libc of your computer. It really uses the libc which comes from Nix. So when you create a binary using devbox, then your binary will have the interpreter here. I learned that a couple of days back, which is set to the libc of the devbox. Now, why is this a problem? When you do a Docker image, at least when I do a Docker image, I do these 2-stage Docker images. So I start with one from, where I do the whole compilation. Then I make a second from, where I just copy the binary into it, which makes that the final Docker image is much smaller. I don't have all the development tools. I don't have all the source code. I just have the binary in it. But if my binary points to this libc part here from Nix, well, this will not be available in the minimum Docker image. So that is a downside, and that is not good. Fortunately, it's Unix, so you can patch elf and set the interpreter here and make it work. But honestly, I feel a little bit uneasy with that solution. It works. It gives me, instead of having a 900 megabyte Docker image with my binary in it, I have a 30 megabyte with my Docker image with my binary in it. So I prefer 30 megabytes over 900 megabytes. But it feels a bit clunky doing this patch elf to reset the interpreter. That's, I opened an issue on the devbox GitHub repository, and perhaps they will tell me a better way to do that. But it works, kind of. Of course, you have some other Rust devbox shenanigans, which you need to find out by writing on their repository. They are really, so they answer quite quickly to questions you have. If you open an issue on the devbox GitHub repository, that is very nice. So I had this problem that I could not. Compile these things, and so they told me I have to add these 6 magical lines, and I added these 6 magical lines, and it worked. No idea why, but it's good. They're reactive. That's good. So for these projects, it's important that people answer issues that you have. I discussed this with Roman Wixinger and with Jamie Cardoso from the ETH library at EPFL, and Jamie said, oh yes, cool, I will try it too. So he made a short tutorial Java project. The link is here in the slide, so you can also click on it. And he said, in fact, once he saw a bit how it works, he was very surprised how easy the installation was. So he's a first-time user. And he even went so far as to create, so he made a Maven project. And what I liked is he started thinking about where things are stored. And all of a sudden he saw that with the Maven project, so this is Maven specific, not devbox specific. With Maven also you can say whether you have the packages per project, so per directory or globally. And so he saw that this might be a problem, that there might be things that don't correspond anymore if you have different projects with different packages. So he fixed that with a Maven configuration. And I thought it was very nice because here DevBox also helped him to understand a bit how this whole environment works and where the things are stored. And just sometimes thinking about this is very nice, and then seeing, oh, I could solve that. And one grief he had was that if you have GitHub actions, making multi-line GitHub actions is a bit difficult with DevBox. Of course, you can use DevBox scripts, but that's also one thing I didn't like too much about DevBox using the JSON. So the JSON configuration files, honestly, I don't know why they chose JSON. I don't like JSON. If I need, JSON is good for exchanging between programs. But if a human has to write the configuration files, I prefer YAML. I mean, you can have comments, you can have multi-line scripts and all that. It's much nicer YAML there. And I don't know why they chose JSON. Anyway, you have some packages which differ between platforms. So, for example, PSUtils, it's not the same on Linux or on Mac. Then all of a sudden you miss commands. That's not good. It doesn't use the system compiler, which is good because it's very rerunnable. But then sometimes with OpenSSL or Rust security stuff, all of a sudden it doesn't work. So you need to go to the repository and ask them why it works. And yeah, somebody complained you don't have a common shell history, but I think that could be solved. And I think currently the biggest problem with DevBox is that you need to install Nix. And currently you need to install that as root. And some people say, I don't want to install this thing as root. So I have one person with whom I work, and she's always like, if a script runs on root on my computer, I want to understand every line it runs. And so when she had to install that the first time, it took her half a day because she had to read the whole script and understand what everything does. It's very good. So now I feel very at ease because she did that. But that's a bit of a downside. You can't install it if you don't have root. So that might be not very, very nice. Yeah. But else, DevBox really, for me, it's a very simple configuration file. It only has what is necessary. It's not like the flakes. It's based on Nix. You have this huge collection of packages, and you even have this DRenv, which can automate it further. Okay, with that, I give back to Roman for the last two slides for the conclusion. And then I hope you have a lot of questions. Okay. Roman?
Nice. Thank you, Linus. Yeah, I saw that there are already a lot of questions. But yeah, maybe we get a little bit more high level again after this nice deep dive. I think, can you see the slides? Yeah, you can see the slides. Perfect. So let's talk about the benefits of proper environment management. Already in the beginning, we saw that it can really save you time in onboarding. Of course, it's nice if your group has like an onboarding document that also explains how to use these tools. And I think this can really save a lot of time. I think it's also great if it's easy to rerun code, to really, when you read a publication, that you can try yourself. Maybe if it's a simulation, just let it run a little bit longer than the authors, then you can check a little bit. And if you want to base your, let's say, your methodology on a specific paper, then you have a head start and can continue this work. So I think their proper environment management can help a lot. Of course, productivity. I think you all know that the pain when the code used to run, maybe in a slightly different setup with slightly different, let's say, package version on a lower level. I think we all know this. And of course, if it's portable, then we can also use it in different domains. And I think this is also really valuable. So to summarize, of course, environment management isn't glamorous, but I think the productivity gains are really, really valuable. And so it's specifically for DevBox. It's a tool that is useful if you want to manage multiple environments on the same computer or system, and it does this on a per folder basis. So all installations are per folder, and you can not only use it for development but also for deployment, as Linus showed. So it integrates seamlessly with Docker. I think this is also quite nice if you can use the same dependencies for dev and then prod. And maybe one last thing, I think we as RSEs, it's always nice if we show to our students and other researchers like what we learned over the past years. And I think this way, as we saw with Nagase-san, this can make the whole group much more successful. And with this, I want to say thanks to Jamie, who supported us in the preparation of this presentation, also provided this nice tutorial. I encourage you to try DevBox yourself. You will be surprised how easy it is to install and just get his API running. I was surprised myself. And with this, I want to thank you, the audience, for your attention, and I'm looking forward to your questions. Thank you.
Great, thank you. Yeah, that was a really, really interesting talk, and I can tell from the number of questions that we've got that a lot of people here are going to be trying that out as soon as they get out of the room, possibly before they get out of the room. Can we switch to the questions on the... Oh, let me sit ahead of us. Right, so the first question from Sean, a lot of the things that needed to go into the devbox.json were unique to the developer's preference, e.g. Vim or LS colors. Is there a way to separate these things from the things that are actually needed for the project?
Yeah, very good question. Ask myself them also. So the LS colors is not only that, but for the environment, I sometimes even add the VS Code, so for the editor, so that I can have the environment also in the VS Code. And I did not find a way yet to separate these correctly. So to have a developer-specific part and a more general part. That's perhaps where you would have to go into flakes from Nix and import things with local preferences, and also solve that problem with shell history, where you want to have a common shell history inside of DevBox and outside. I think for me, the big advantage of DevBox.json is that it's so simple. The file is really simple. The disadvantage is that, well, it's simple. So yeah, if you want to have these things, I think you have to go to Nix and write Nix flakes. But as I said, I was afraid of doing that. So I'm very happy with DevBox.
Okay, thank you. So we have another popular question about DevBox. The name clashes with a Microsoft DevBox, yes. But some people have already answered that in chat. It's jetify.com/devbox. Is that the correct one?
Yes, exactly. Yes. So thanks to Google, whenever I search DevBox, I have the Jetify DevBox. But if you search yourself for DevBox, yeah, that's one thing I should have put in the slides, the link for DevBox. So it's Jetify DevBox, exactly.
Thank you. And next question.
No, I didn't answer this question from the lightweight thingy. Difference between Docker?
Yes, yeah. So from what I understand, okay. So this is from Saranesh. From what I understand, the major difference between DevBox and Docker is how lightweight containers DevBox creates. They are almost alternatives to each other between DevBox and Docker. If so, is it still better to just have Docker containers for smaller projects? Where's the line where a user should switch from Docker to DevBox?
Okay, so the Docker and DevBox are in fact two technologies which are very different. Docker, if you're on a Linux machine, Docker uses something called Linux namespaces, which gives a complete separated environment. If you run it on Windows or on Mac, you actually need to run a virtual machine with a Linux kernel inside to use the Linux namespace to then use your project, which is kind of heavy. They made it very fast, which is nice, but it's still quite heavy. DevBox just uses the path variable. And so the path variable is where the shell will go and search and look for binaries. So DevBox only changes that path variable. It doesn't do any virtualization. It doesn't do any namespace, nothing. It just tells the shell where to go for the binaries, and then the binaries are compiled natively for your machine. You don't have any virtualization inside there. So it's much faster. It's much more lightweight. And from that point of view, you're much closer to your computer than if you use Docker.
So just to pick up on that, does it also set things like LD library path to pick up shared library locations?
Good question. I couldn't answer that, but so, seeing that it links it to the libc of Nix, I think it does it, yeah. I would have to look into it, but I think it does.
So for Rust, it's all statically linked, so that wouldn't be a problem, but for other things...
Yeah, Rust is statically linked except for the libc, which is the problem I run into.
Right. So we've got another question from James. Does DevBox work nicely with IDEs? For example, running linters and tests and things like that?
Yes, so as I said before, I have the tendency now to put in my DevBox JSON VS Code. So from the shell, I run code, and then it opens me the Visual Studio Code so that it uses the Rust linters and all that from the DevBox environment. There is a plugin in Visual Studio, but I never got it to run to actually use the DevBox setting. It should be possible. I tried it many times. It never worked. So now I just run it from the DevBox environment, and that works for me. Yeah.
Okay. We have plenty of time for questions, which is just as well because there's lots of questions.
Okay.
Another question from Sherman here. How does this extend to HPC systems with a scheduler?
Badly. I discussed with, I don't remember his name. It's unfortunate because he gave me a lot of information with HPC systems, and he was like, they tried DevBox on the HPC systems, and the problem was less with the scheduler than with the weight of the Nix system, because you need to share all these things between the machines, and it seems that is sometimes difficult between HPC systems to have a common directory, and then it's a bit slow because it's all over the network, and it doesn't really work nice. So I think the scheduler is not the problem there. It's more the problem of having this shared Nix directory that needs to go over the network and which slows it down. So he said he's using SPAC. They tried to use DevBox, but in the end they just used SPAC because it was easier for them.
Okay, we have several questions here which are kind of on a theme, and will actually really nicely segue into our next talk, I think, which are about how does DevBox compare to other tools in the same space, such as Vagrant, or I've lost the other,
there was
or Conda, for instance.
Yeah. So to me, there are two big advantages of DevBox. One is it's based on Nix. So you have these 80,000 packages with 400,000 versions. Not every package, but overall the packages. And the second is this DevBox.json is very simple. So these are, for me, the two big advantages of DevBox. And so I really like this. I tried a bit of Vagrant, I tried a bit of all these other tools, but they were, to me, always complicated to set up.
Okay, thank you. In that case, let's thank our speakers, Linus and Roman, again.